Hi, my name is Hannah Matison. Today I'm going to be showing you how I did my project for fluids. So first I'm going to go in with Fluent Flow and click on that and drag it. And then I'm going to change this and we're going to do the Poiseuille flow first. So then we're going to right click on geometry. Oops. It's just loading right now. So do this every single time. Okay, so I'm going to go to geometry, right click on it, and go to new design module geometry. And then it should upload a new screen. There we go. So now that we're in this view, we're gonna go and change it to Z, and then we're gonna go up to sketching, and then we're gonna go to rectangle, and we're gonna start from the origin and then draw out. Then we're gonna go to dimensions, and I usually just go to general, and then the dimensions for the first one was 300 millimeters in length and 2 millimeters in height. So, oh wait, I forgot to change my units to millimeters. So we're going to change this to 300 millimeters in, or no, 2 millimeters in height. Nope, 300 millimeters in length and 2 millimeters in height. Now it's going to look kind of weird because I drew them up, but this is our little box right here. So now we're going to go to concept, surface from sketch. We're going to go and click on the box, and then we're going to click apply, and then we're going to generate that. And then once it's done generating, we're going to go back to our workbench. And then there's a check mark, so that's good. So then that's all we do for that one. And then we're going to double click on the mesh. And down here it says that it's starting meshing, so it should pop up soon. So now that the mesh, oh wait, that's not the mesh. Now the meshing is popping up. And so now the meshing is popping up, and what I'm going to do now is change that Z so we can see it, and then we're going to zoom in a little bit so we can see the corner, these two corners, and we're going to change it to edge, and then we're going to click, oops, edge. We're going to click on edge, and then we're going to right click, then we're going to go to create name section, and we're going to name it upper wall. And then it's going to go down here to name sections. And then we're going to go to the bottom one, right click. And then we're going to call it lower wall. And then we're going to go to the two edges, which are a little hard to get sometimes. And then we're going to right click after we selected our edge. And then we're going to call this one the inlet. And then this one over here is going to be called the outlet. So we're going to click on it, right click, and we're going to name it outlet. And then once we go to our name sections over here, we can see that each one of those has been named. So what we're going to do now is we're going to click on mesh. We're going to right click on mesh, insert, sizing, and then we're going to press the central key on our keyboard, click upper wall, click lower wall, and then go over to geometry where it says no selection, hit apply. For element type, we're going to change that to number of divisions. We're going to make this 2500. And then where it says curve or curvature, we're going to click no. And then we're going to change the behavior from soft to hard. And then we're going to click generate. And then it's going to generate our mesh, which takes a while. Okay, now that it's done meshing, we're going to go and do the same thing, but for the edges. So we're going to, or first we can click on mesh and then zoom in. We can see that it is meshing. And then we're going to go right click on mesh, insert, sizing. We're going to press control. And then click on each edge. Then we're going to go and click apply. Element size, we're going to change that to number of divisions. Change this to 50. Capture curvature, we're going to change that to no. Then we're going to change the behavior to hard, just like the other one. Then we're going to generate the mesh, which will also take a while. Now that the mesh is done, we're going to go and we can click on the mesh and see that it did mesh some more. And then we're going to click on the mesh, then we're going to go to face meshing, and then we're going to click apply. Oh, whoops. We're going to click on the square. We're going to click apply, and then we're going to click generate. This one usually doesn't take as long as the other two. So now that that's done, we're going to go into the other screen. Oops. We're going to go to Workbench, and then we're going to click on Mesh, and then we're going to click Update. So now that there's a green check, we can go into the setup. So we're going to double click on setup. And then it's going to open a new tab for us. And it shows this as it says Fluent Launcher, and then we're going to click on double precision on the pop-up and click start. That the setup opened, it looks like this. And then we're going to go into, oops, it's not done yet. So now that the setup is done, we're going to go into our models and we're going to change this. We're going to right click on viscous and we're going to change that to laminar. All of them are going to be laminar. And then for every single like flow, they're all laminar. And then we're going to go to our fluid and we're going to go, we're going to go to fluid up here. We're going to double click on that. And it's going to open for us. And then we're going to change our density to 1. And then we're going to change our viscosity to 1e to the negative 5. And we're going to go to change and create. And then we're going to close that. And then we're going to go up to our results and our residuals. And then it's going to show this. And we're just going to change all these to 1e to the negative 6. And we're going to press OK. And then we're just going to make sure over here, under the cell zone conditions, we're going to go to surface body fluid. And then we're just going to make sure that it says air over here, and it does. So then we're going to press apply and close. And then for our boundary conditions, we're going to go to our inlet, and it should say velocity inlet. So we're going to double click on that. And then for the velocity magnitude, I'm going to change that to 0.4, apply, and then close. And then we're going to go to our internal. We don't do anything there. Our outlet, we're going to double click on outlet, not wall. For outlet, we're going to click on prevent reverse flow, apply, and then close. Wall, we're going to double click on lower wall. And we're going to make sure both of them for this flow condition are both stationary and no slip. So apply, close, and click on upper wall. And make sure you apply and close this one as well for stationary and no slip. So now that that is done, we're going to go to our reference values and make sure that they are all correct. This one does not look correct, so we have to figure that one out. But we're going to go to compute from and we're going to change it to inlet and reference zone surface body. So to change our viscosity, um, oh, it just changed. It just updated. Perfect. So it updated. It was just being slow. And then we're going to click on initialization. We're going to double click on initialization. We're going to click initialize, and usually it runs 10 iterations. And then when it's done, we're going to double click on run calculations. And then we're going to change this to 150 iterations. And then we're going to click calculate, and then it's going to calculate 150 iterations. So when it's done, I'll come back. So now that our calculation is complete, we're going to press OK. As you can see, calculation is complete, and we're going to go back to our workbench. One second. So now we're going to go back to our workbench. And then we see that there's a check mark next to solutions. Now we're going to double click on results, and it's going to open a new screen for us. So now that we're in our results screen, It's taking a little bit to load. So now that we're in our results screen here, we're going to change that to make sure we only see the Y and the X. We're going to go to insert, we're going to go to location, line, and we're going to create a midline. And then our point of the midline is going to be whatever our middle point of our length was. So mine was 300 millimeters, so I'm going to make it 0.150. And we're also going to change this to 0.150. And then this is your height. So it's 2 millimeters, so I'm going to make that 0.002. And then our samples is going to be 100 samples, and we're going to click apply. And then you can see our midline is right in the center, it's yellow, and then we're going to go back to location, create another line, create another line, and then we're going to make this our end line. Okay, and then since our length was 300 millimeters, I'm going to change it to 0.299 just so it gets to the end and not exactly at the end, but a little before it. And then this is our height again. We're going to change the samples to 100. We're going to click apply. And then we're going to go up here to contour line. And then we're going to click OK for our contour line. And we're going to change our location to symmetry 1, our variable to velocity U, our range stays at global. We're going to change the number of contours to 110. Then we're going to click apply. And then this is what our contour line should look like. And then this is in scientific notation, so we're going to go over here to our legend view, the default legend view. Double click on that, and then we can change the appearance to vertical or horizontal, but I usually leave mine at vertical. And then the appearance, we're going to change that to fixed, and then we're going to click apply. So these are the values that I get. And then we're going to go and click on chart up here. Okay. And we're going to change the title to velocity velocity contours for Poisson flow. And then we're going to go to our data series and we're going to click on this icon over here. We're going to change this one to midline, and we're going to change our location to midline. In series 2, we're going to change the name of it to end line, and we're going to change our location to end line. And then our x-axis is going to be velocity u, and our y-axis is going to be just y. So scroll down to y, then we're going to click apply, and then our chart will generate. And then a thing about this chart is the midline and the end line are overlapping. So due to that reason, you're not going to be able to see the midline unless you delete the end line, and then you'll be able to see the midline. But this is how you get the graph for the Poisson flow, and this is the same for the other two flows that we are doing in this project. But for the mesh and the generation of the rectangle, it is all the same. However, you do have to change your height and your length based on what you are doing for the project. So I changed my height for the Coet flow to 10 millimeters and the length to 1500 millimeters. And for the hybrid, I changed my length to 240 millimeters and the height to 1.6 millimeters. And then for the co-wet flow, I changed my velocity of the upper wall to 0.002 meters per second. And the viscosity is 1 times 10 to the negative 3 kilograms per meters per second, meters times second. And the density for the air is 1 kilogram per meter cubed for every single flow. And then the length, or for the hybrid, I used inlet velocity is 0.05 meters per second, and the velocity of the upper wall is 0.02 meters per second. And then at the end, I exported my data, and then I put the graphs into my lab report, and I made sure to get 5 values for the maximum velocity and their heights. And then I solved for the Reynolds number for developing region and the laminar flow assumption. And yeah, thank you so much for watching my video. Looking forward to doing this for the next project. Oh, yeah.